In this next video, we're going to go back to factoring quadratics, factoring trinomials, that x squared. Call that a quadratic. But this time we're going to see quadratics where there's a lead coefficient in front of the whole thing. We call that the a. The reason we call that the a is because we just need to give a name to the three coefficients in each term. And so we call the first one a, the second one b, and the third one c. So whenever that a is not 1 and there's no GCF to take out, we're going to need a new method for solving it. We're not going to just look for numbers that multiply to -3 and add to 5. That doesn't work, aside from the fact that there are none. Even if there were, it wouldn't work. So the process is a bit longer here. Instead of looking for numbers that multiply to -3, we are going to multiply that lead coefficient, the a, and the c together. So in this case, that's 12 times -3, which is -36. And instead of looking for numbers that multiply to -3, we're going to look for numbers that multiply to this, to -36, and add to that b in the middle. So we need numbers that multiply to -36 and combine to 5. If you don't know it right away, that's totally fine. Just start making your factor pairs of numbers that multiply to -36. Because they have to combine to a +5, the bigger one's going to be positive. So either -1 and +36, or -2 and +18, or -3 and +12, or -4 and +9. There's only one more pair of factors that goes into 36. It's -6 and +6. And the one that works here is -4 and 9. So this is a lot like the other factoring we've done with the trinomials when there was no lead coefficient. We would look for numbers that multiply to that c and combine to 5, the b, the middle coefficient. When there is a lead coefficient, we just need to do one small thing before we choose those numbers, and that's multiply the a and the c first. Great. But our factors are not just x minus 4 times x plus 9. Obviously, that doesn't work. That doesn't multiply to 12x squared. Right? I can write that out just to show you how far off it is. We have these two numbers, x minus 4, x plus 9. Don't write this down because it's not right at all. Clearly, when we multiply them together, we would start with x squared. That is definitely not right. So here's our trick. Instead of just sticking those numbers into parentheses like we do with the trinomials when the a is 1, what we're going to do is rewrite that bx. We're going to chop this 5x into 2 pieces, so that way we can have a 4-term polynomial instead of a 3-term polynomial. When we choose the numbers -4 and +9, what we're doing is picking the numbers that we're chopping the 5x into. So I'm going to rewrite this as 12x squared, and the order I do this in does not matter, minus 4x plus 9x minus 3. And so what we've done is we've taken the 5x and chopped it up into -4x plus 9x. That's totally allowed. I can rewrite 5x that way if I ever want to. The reason I do it is so that I can then do my next step, which is factoring by grouping. So I'm going to break my terms into pairs, and if you don't write down this step where you break them into pairs with parentheses, that's okay. I'm going to do it because I think it's helpful, but if you skip that, writing it with parentheses, that's okay. And then I'm going to factor out, this is the system we had in the last topic, the last factoring by grouping. I'm going to factor out the GCF. I'm sorry, by the way, I made a mistake when I wrote that. That should be minus 4x. Right? The x is still there. So when I factor out a GCF, I'm going to pull out a 4x, leaving me with 3x minus 1. And from the second pair of terms, I can factor out a 3, which also leaves me with 3x minus 1. And again, this is that 3x minus 1, 3x minus 1. That's what we need to see. That's what allows us to continue factoring, undistribute the 3x minus 1, because now that's the greatest common factor, leaving me with 4x plus 3. And that's your answer. We can practice with a couple more of these. Remember, the idea is we're going to multiply the a times the c, which in this case is 4 times 15, and then look for numbers that multiply to 60 and add to negative 16. This one I'm guessing a lot of you are able to see right away. Keep in mind that because they're multiplying to a positive 60 but adding to a negative 16, that means both will be negative. And the numbers that work here are negative 10 and negative 6. So what we're going to do is chop that negative 16x up into two pieces, negative 10x minus 6x. And so when we look at these four terms, we can say, all right, well, it's four terms now. I can make two groups, and I can factor by grouping. Notice how, remember, when I rewrite this, I want to make sure that the groups are separated with the plus sign. But since this 6 is negative, I'm going to need to include that negative 6 in here. And then I can factor out both pairs of terms. There's a 2x I can factor out here, leaving me with 2x minus 5. And there's a negative 3 I can factor out here. Notice I'm going to pull out the negative because I always want this first term to be positive. I have to rewrite that. So I want that first negative 6x to be positive, so I'm going to pull out the negative, which also leaves me with 2x minus 5. And so that 2x minus 5 and 2x minus 5, those are the common factors that I can now undistribute, leaving me with 2x minus 5 times 2x minus 3. Sorry, you might have noticed I made a mistake when I wrote this. That should have been a 3, not a 2. We can do one more. So 24x squared minus 4x minus 8. We can jump right into this thing if we want, like find the a times c and do all that. But I do want you to be on the lookout for problems when there is a GCF to pull out first. 24x squared minus 4x minus 8. I can pull out the 4 first, which just makes my life a little bit easier. That means that every step of the way there's going to be a 4 every step of the way. There's going to be a 4 on the outside. It's never going to go away now. But I can just factor the 6x squared minus x minus 2, which is a little bit easier because the numbers have shrunk a little bit. So we're going to, remember, multiply the 6 times negative 2. And so we're looking for a number that multiplies to negative, a pair of numbers that multiplies to negative 12 and combines to negative 1. That's negative 4 and 3. If it takes you longer than just a second to find those pairs of numbers, remember, just start making a list like we did up here. So I'm going to rewrite that 6x squared minus 4x plus 3x minus 2. Notice how what I'm doing is rewriting the middle term. It's a little bit off center right now, but I wrote that negative x as negative 4x plus 3x. That's the idea here. And then we can factor by grouping. So I'll pull a 2x out of the first group. And if there's nothing to pull out of the second group, that's okay, because the second group is already 3x minus 2. And so I can undistribute that 3x minus 2. And then what I'm left with is 2x. There's an invisible 1 in front of that. So 4 times 3x minus 2 times 2x plus 1 is my final answer. I'm going to change the parentheses color there because that was confusing me. And that is how you factor when there's a lead coefficient in front of the polynomial.